In the last video, I introduced the idea of using an indicator variable to model a qualitative predictor. So the example we used there was where we had different job titles, managers and clerical workers, and we had an indicator variable that was either 0 for one of those job titles or 1 for the other job title. So I'm going to push that idea a little bit further in this video so that we can really understand the role of an indicator variable in a multiple linear regression model. So we have some data here on salaries with workers with different years of experience, and then I've also recorded the genders of the workers. And we're using an indicator variable here, D, that is going to have the value 0 for females and 1 for males. And we showed last time that it doesn't really matter which way round you do this, just as long as you keep a record of it. So just arbitrarily we've used D equals 0 for females and 1 for males here. The question that I'm posing here is, if we're looking at workers with the same amount of experience, who gets paid more, males or females? So we've got a male and a female with 2 years of experience. The female gets $1,000 more. Two workers, male and female, with 3 years of experience. Again, the female gets $1,000 more. Two workers with experience of 4 years, male and female, the female gets $1,000 more. So it looks like the answer to this question, or these two questions, is females are getting paid more for the same amount of experience, and they're getting paid more by $1,000. So if we were to look at this in a scatter plot, it would look like this. So the F's are the females, the M's are the males. We've got experience on the horizontal axis, salary on the vertical axis. And if we look at the two workers with 2 years of experience, the female is $1,000 higher than the male. Similarly, for 3 years of experience, the female is $1,000 higher than the male, and similarly for 4 years of experience. So it looks like that the difference between females and males is $1,000, and it looks like that's represented by the vertical distance between these two regression lines that I've got marked on the plot. So how does this show up in the model results? Okay, so let's put this data into R. Okay, and I've got my indicator variable D that is going to be 0 for females and it's going to be 1 for males. And then I'm going to fit my model with experience and D, and then I'll summarize it. Okay, so I've got an intercept term of 25, a regression parameter multiplying experience of 1, and a regression parameter multiplying D of -1. Okay, so drawing this on a graph, so I'm just going to replicate the graph that's on the slide. Okay, so the equation of the graph for, well, let's do D equals 0 first. So D equals 0, we just got to remember which is which. So D equals 0 was for females. So the female line is going to be plug in 0, so we can ignore this row in the coefficient estimates, and we're going to have 25 plus 1 times experience. So the equation of this line is 25 plus 1 times experience. And then plug in D equals 1 for males, so now I'm going to have 25 plus 1 times experience minus 1, or if I simplify that, it's going to be 24 plus 1 times experience. So the equation of this line is 24 plus 1 times experience. So what's the difference between these two lines? Well, it's just the difference in the intercept. And so the difference in the intercept is given by this regression parameter here, the one that goes with D, the -1. Okay, that's the difference between males. Let's get this right. It's the difference between males and females. Okay, I'm saying it that way round because males had d equal 1 and females had d equal 0. So the difference between males and females, difference between the category that's coded 1 and the category coded 0, that difference is given by this regression parameter estimate here. Okay, so that's how to interpret the regression parameter estimate for an indicator variable. It represents the difference between the category that's the value 1 for that indicator variable and the reference category that has the value d equals 0. And we've got to keep in mind that we're keeping the level of experience fixed when we make that interpretation. So when experience is equal to 2, say, the difference between males and females is -1. When experience is equal to 3, the difference between males and females is equal to -1. When experience is equal to 4, the difference between males and females is equal to -1. Okay, so that's interpreting the regression parameter estimate for an indicator variable. And we have to think about what is the category that's denoted by a value of 1, which in this case is male, and what is the category denoted by the value d equals 0, and that's female in this case. Okay, so let's do another example where it's a little harder to do this just in your head. We're going to need to rely on the software to figure out the equations for this example. So let's look at this data. So here's my data. I'm going to set it up the same way. Okay, d equals 0 is going to be for females, and d equals 1 is going to be for males. And then I'm going to fit my model. I'm going to summarize it, and I can draw a picture of what it looks like as well. Let's do that. Okay, so similar picture to the last one. I've got females having a higher salary than males for the same amount of experience, and now I want to figure out, well, what's the difference between males and females for a fixed level of experience? In other words, what's the vertical distance between these regression lines? Well, it's given by this estimate here. Okay, again, it's pretty close to $1,000. If I was to round this to 3 decimal places, I would get -1.000. What about this example? Okay, so this example, let's take a look. If I was to look at a graph of this example, okay, this one's a little more complicated. If I look at the relationship between experience and salary for males, I've got M. It's kind of, if I trace out the trends there in the M's, I'd be something like this. The F's I've got here, and here, so it's a shallower line. It looks like if I was to trace out those trend lines, they would cross. Okay, so that suggests interaction. Okay, we talked about interaction in a previous video, and if we've got crossing regression lines with different slopes, they don't necessarily have to cross, but regression lines with different slopes, that indicates interaction. So let me create my interaction term. Okay, just exactly as we discussed before, you just multiply the variables together. So in this case, I'm multiplying d and experience. These are my two predictor variables. I'm just multiplying them together to get an interaction term, and then I'm fitting a model, and then I'm summarizing it. And then if I draw these regression lines onto my graph, okay, those trace out those trends that I was talking about. How do I get the formulas for those two lines? Okay, so here's my regression equation. Okay, I'm just getting that from these numbers: 25.155, 0.748, minus 2.033, and 0.697. Okay, and I'm going to do exactly what I did before. I'm going to plug in d equals 0 to get my equation for females, and plug in d equals 1 to get my equation for males. So if I plug in d equals 0, these two pieces of the equation will go away, and I'll be left with 25.155 plus 0.748 times experience. If I plug in d equals 1, okay, if this is 1 and this is 1, I'm going to have 25.155 plus 0.748 times experience minus 2.033 times 1 plus 0.697 times 1 times experience. And now if I simplify all that, I'll have for an intercept for males, I'm going to have, let's just do this in a side calculation over here in R. I'll have 255.155 minus 2.033 times 1. So this will be my intercept for males. And then what about my slope for females? It'll be, sorry, for males. It'll be 0.748, 748, and then I'm going to have plus 0.697 times 1 times experience, so 0.697. So 0.697. And that comes to 1.45. So the prediction equation for males will be 23.122 plus 1.445 times experience. Okay, so the intercept's a little lower, but the slope is bigger. So it's a steeper line with a lower intercept. Okay, and that was what we saw in this graph, right? The line for males has if we were to extend this back to see where the intercept was, where it crossed the y-axis when experience is 0, it would cross at a lower point than the F line, but it's got a steeper slope. It's got a slope of what did we say? 1.4545 rather than 0.748. Okay, so now if we think about what these numbers mean, okay, we already decided that the minus 2.033 that is representing the difference in the intercepts, okay, because it comes into the calculation here. It's the difference between 25.155 and 23.122, whereas this number, the 0.697, that's the number that represents the difference in the slopes. Okay, so that's how to interpret the regression parameter estimates for not just the indicator variable itself, but also if there's an interaction between the indicator variable and a quantitative predictor. So that's a fairly in-depth discussion of using indicator variables for a qualitative predictor with 2 levels. Okay, there's many instances of qualitative predictors with more than 2 levels, however. So in the next video, I'll talk about how to incorporate indicator variables when we've got more than 2 levels.